Hello, everybody. Hey, this is our next lecture. This lecture is on forces. This is it. The next additional thing that we're going to see in physics. So, what is a force? Okay. So, if you were trying to explain what a force is to, let's say, a kindergartner or a first grader, the simple explanation or definition would be a push or a pull. Okay. So we're going to say push or pull. All right. So pretty simple. Now, remember, if you have a push or a pull, that doesn't necessarily mean it's going to move. Okay. In the same way that if I take this board and I push on it, it doesn't necessarily move, right? But I can push on it and get it to move. Okay. But obviously, if we're going to get something to move, okay, or change its motion, then we're going to need some forces. Okay. Now, we've already talked about acceleration, and acceleration is a change in velocity, which means it can either speed something up, or it can slow it down, or it can change direction. So, what else is acceleration? And acceleration is equal to the force divided by the mass, So we have not talked about what mass is per se, but remember in that very first assignment, one of the 6 things that we were having you look at is what is mass. And you guys, what mass, we can just really kind of define it going back to our kindergarten stuff, our kindergarten explanation. It's just stuff, okay? It's just stuff. All right, so we're going to have units of kilograms, okay? You're probably familiar with kilograms, and that is the basic unit that we're going to use, okay? And remember that we also have acceleration. The units for acceleration are meters per second squared, okay? And if we go back and we change this equation around, okay, we can say force is equal to mass times acceleration, okay? And the units for mass is kilograms. The units for acceleration are meters per second squared. And therefore, the units for force are kilogram meter per second squared. And that is known as a Newton, okay? So the units for force are newtons, and it was named after Sir Isaac Newton, who had 3 very famous laws on the laws of motion plus gravity, and we will get more into that as well. Okay. All right. So when we move on through this class in this week, we're going to talk about mass. But since mass is also going to be the ratio of the force divided by the acceleration, okay, we can see that if you have a if you have a high force and a low acceleration, that would give you a bigger mass. Okay, high force, lower acceleration. Okay, then that would be a bigger mass. If you had a high force and a higher acceleration, okay, then that would be a smaller mass, okay? So anyways, we can look this equation right here, and this equation right here, and this equation right here. You guys, these are all 3 of the same equation, They're just rearranged. In a different math or algebraic notion, okay? So let's do some few basic force equations. Now, You guys, what's going to become really important for you to understand the question is to draw a picture. Okay, and our next lecture is going to be something called free body diagrams, but for right now, we're just going to talk about, let's say we have a 1 kilogram object, and we are going to have a force that, let's say, is 4 newtons. 4 newtons. Then, what is the acceleration going to be? What is the acceleration going to be? So F equals ma, and we want to know what the acceleration is, so we can change that around. Acceleration is going to be force divided by mass. Our force is 4, and our mass is 1 kilogram, and therefore our acceleration is going to be 4. Okay, now the units for acceleration are meters per second squared. Okay, and to show you that, remember, if we go back to what a Newton is, that is a kilogram meter per second squared. And if we line those up, those kilograms cancel out and we're left with meters per second squared. Meters per second squared. All right, you guys, let's say that we increase this mass to 2 kilograms, Now, if this was heavy and we had the same force, would that mean it would accelerate more or accelerate less? Okay, so think about that for a minute. Now, based on your own experience, I hope you would have said that it's going to accelerate more slowly because we have a bigger mass. Okay, so now we're just going to plug in the same equations. We'll just plug in these numbers. Acceleration is going to be 4 newtons divided by 2 kilograms, and that is going to give us 2 meters per second squared. And obviously, since we doubled the mass, we cut the acceleration in half. Okay, so going back to our relationships over there, okay, if you have a high mass, with the same force, it's going to accelerate slowly, and if you have the same force on a smaller mass, it's going to accelerate more. Okay, all right, we're going to do another couple questions here, and let's take a look at what if, again, we had a box and it was 5 kilograms and we had an acceleration of 2 meters per second squared. Okay, then what would the force be? What would the force be? Okay, so if you look here, we can say F is equal to ma. Now remember, we end up having 3 equations. Acceleration is force divided by mass, F is equal to ma, and m is equal to F over a. Now, I don't want you to have to remember 3 equations. So if you just remember F is equal to ma, then you can change it around algebraically to get the other 2, all right? But now remember, we don't have our force, but we do have our mass and we do have our acceleration. So now we have our equation here. So we're going to put in 5 kilograms and an acceleration of 2 meters per second squared. And that is going to give us a value of 10 kilogram meters per second squared. But remember, a kilogram meter per second squared is also known as a Newton. So our force here would be 10 newtons. All right. Lastly, let's take a look at a question. that we have a object here, and now we don't know what that mass is. And let's say we have a force of, let's say, 15 newtons. And we know the acceleration is equal to 3 meters per second squared. Okay, what then is our mass? What then is our mass? Okay, so we're going to go to F equals ma, and we remember we want mass, so we're going to divide both sides by a because we want to get mass all by itself. So now we know that the mass is equal to the force divided by the acceleration, okay? And now we can plug in our numbers. So we know that our force is 15 newtons, and we know our acceleration is 3 meters per second squared, and 15 divided by 3 is going to be 5. Again, you know that mass is going to have a unit of kilogram, so you can just go to there. But I'm going to change this newton to kilogram meters per second squared, and we can see that the meter per second squared and the meter per second squared is going to cancel out. So we can see that our mass is going to be 5 kilograms. Okay, to review, a force is just a push or a pull, okay? Now, a push or a pull is going to have a direction. So what kind of unit or what kind of number is acceleration? Is it a scalar or a vector? If you go back to week 1 or 2, week 2, you may remember that a vector has direction. Now, I didn't talk about here, but if you look at where I'm putting arrows, we can see that if the force is going this way, the acceleration is going that way. So I've used arrows, which is telling you what the direction is. And if we're doing something like this, we could say right or left or up or down, or even give it a certain angle, okay? But, so force is going to be a vector unit, just like acceleration. Mass is a scalar unit. It does not matter. You either have mass or you don't, or you have more or you have less. Mass does not have a direction, so mass is a scalar. All right, so there are 3 ways. There are 3 ways to set up the basic sort of math in a force equation. Since we've got 3 variables, F is equal to ma, okay? If you have 2 variables, for example, m and a, you can calculate force. If you have force and mass, if you have force and acceleration, you can calculate mass. And if you have force and mass, you can calculate acceleration. All right, ladies and gentlemen, we will come back to you with another lecture that is going to work on more forces. All right.